Normally when we talk about Azure networking and VNets, hub-spoke topologies, virtual WAN, etc., we're talking about common layer 3 routing domains where we have unique IPs across Azure and on-prem. There are some customers and scenarios, however, where the virtual networks are used in a slightly different way, where the approach is teams are given their own isolated virtual networks with a address space which could perhaps be large and both overlapping with other areas of the business and maybe with each other. So in this environment here we're looking at, there's two separate VNets owned by two different teams who are off doing their own things in Azure, deploying things inside of their VNet, using PaaS services, etc., with autonomy. But you can see here that the VNets have been given the same CIDR range. And let's say you expanded this out to 50 VNets or 100 VNets. So you have a more distributed approach to the cloud and networking. Now let's introduce a requirement or scenario where these workloads need to reach out to the internet. Let's say they are an application that's reaching out to a third-party provider, SaaS provider, or business provider, business-to-business communication over the internet. And how would that traffic go out of Azure to the internet? Well, today we have things like default internet access, soon to be removed from the platform next year. You could look at using NSGs, which would be rather unscalable and impractical for outbound internet access. You could put firewalls locally in these VNets, but that would get expensive. So you may have a requirement where you want to have this distributed, sometimes called disconnected scenario, and implement an element of centralized control for internet egress. And whilst this is not the only option, in this video, I want to highlight an interesting use case where we can use Azure Private Link and forward proxies to implement a level of centralized control for internet security whilst retaining a distributed approach to private IPs and VNets. So here we've updated our topology, and let's walk through what's happening here in the abstract, and then we'll go through a demo in the portal configuration. So in each VNet, we've now introduced a private endpoint, and we define that private endpoint IP as the destination for a proxy on the virtual machine. So either in a system level setting or in a web browser, when we send traffic out to the internet, we'll use that proxy and it will go to the local private endpoint. We've then used private link, these lines here representing the private link technology, to map it to a private link service, which effectively is the way of using private link to get to other VNets and the provider and subscriber model, not to get to an Azure PaaS service in this example. The traffic comes into a private link service, and we've mapped that private link service to a standard load balancer, and the back end of which is our proxy service. So in my example, I've just got a Linux virtual machine running Squid proxy, but this could be a standard load balancer going to a pair of NVAs, for example, running a proxy service. We've got other videos on private link service and private link, but roughly how this would work is traffic would come in, and private link is agnostic to the source IPs here. Hence, we can deal with these IPs can be overlapping. They could even overlap with the hub space. That wouldn't be a problem. And when the traffic pops out of this private link service here, it gets source nattered or snattered to a range that you specify. And the range that I've specified is 10.10.7.0, which is a subnet inside of this VNet. So when the traffic goes through the load balancer and hits the proxy service, the traffic looks like it's sourced from this range here, not that it's sourced from the actual VNets that sit behind the private link service. And there are things we can do with the TCP proxy protocol to embed the originating IP address, etc. So I'll show you what this configuration looks like and demo it, but what we can see here in the aggregate is we're able to leave these VNets overlapping and disconnected whilst providing a centralized way of securing the outbound traffic if it's proxied. Of course, the elephant in the room here is, what if there's compute nodes and workloads here that are not able to use a proxy? I'll demonstrate that, well, that traffic would just egress locally via whatever methods configured on that VNet. So that whilst this doesn't fit all use cases, it could be a useful tool if you have a specific requirement such as this. So first things first is just to validate the forward proxies working from a local VM. So I've got a VM here in the same subnet with IP 10.10.3.7. And inside of it, I've configured the web browser to use my forward proxy. We can see that here in my web browser 10.10.3.4 and port 3128, which maps to the default port that Squid proxy listens on. And when I try and browse to a website here which tells you what your IP is, notice this IP coming back here, 20.4.66.192, and that's actually the public IP, not of itself, but of the proxy VM. So that's operating as we would expect. And you can further confirm this by, on the same machine, going to a similar website via a method that's not using a proxy. In this case, I'm going from the command line. And if I curl a website that brings back your IP, you see I get back a different IP. So this is the actual IP of the VM. So that's non-proxy traffic, just egressing locally. So we can see that our proxy is working functionally. Also on my Squid proxy, I've put a rule in that denies any traffic to websites with Microsoft.com in the name. And we can confirm that I've gone here to azure.microsoft.com, and you can see a Squid error message, access denied. So that proves our proxy is functioning from our local test virtual machine. And now we'll just show it working from a VM in a disconnected spoke. So this is my disconnected spoke VM. Notice that my proxy now is specified at 10.4.0.5, which, just to remind ourselves, that's our local private endpoint, which makes sense, right? Because it's in the same VNet. I've got layer 3 reachability to the proxy. And in a similar fashion, if I go to a website, I can load it up and I can prove that the proxy is working. Similarly, if I go to a website that tells me the IP address, this is the IP address of my centralized proxy, which I'm using via private link. If you're interested in the Squid proxy verification, you can look through the Squid proxy logs, and you can see, for example, that here's the particular HTTP packet that I just sent there, going to that test website, the one there. And the interesting point here from the logs, which we can refer to on our diagram, is that indeed the Squid proxy sees traffic coming from 10.10.7.4, which is the IP address of our defined SNAT subject on the private link service. So the traffic's going over private link through the private link service and getting snatted there. We can verify that in the portal. This is the private link service definition. We can see, for example, there's my private endpoint that's approved and connected. And in the NAT configuration, you can see that I've defined the subnet. And at the moment, we only require one IP address to deliver all the required SNAT ports, and it's dynamically assigned that 10.7.4 address. If you had hundreds of VNets and many clients, it would automatically give you more IPs. So you may see the traffic come from 10.7, 10.10.7.4.5, etc. And it would hit your centralized appliance coming from that IP. And we mentioned before around, you do have the ability to leverage TCP proxy if you want to kind of do a similar thing to X-forwarded 4, but TCP proxy, of course, is working at a different layer to HTTP headers. Anyway, I just thought that was an interesting one to share, which kind of shows some interesting scenarios, perhaps out of the box ideas when it comes to having an element, should we say, of centralized control whilst giving autonomous functions to application owners. And you could probably imagine some other designs that would be possible, which are along these similar lines. For example, centralizing DNS resolution with the Azure DNS resolver and cross-tenant links, that sort of thing. But anyway, thank you for watching. I hope you found it interesting. Ping any questions in the comments.